Okay, we're going to move ahead then really quickly here to example number 5, just to try to take a look at this. All right, in example number 5, let's suppose the following scenario happens. Suppose that I hand you a coin and I tell you that the coin is fair. By fair, I just mean that it has an equal chance of flipping heads and tails. Like, it's not a trick coin. I'm not trying to, pull one over on you. But then, of course, keep in mind, you might look at me and you might say, I don't know, Kyle's kind of a fishy guy. Maybe he would lie to me. Just because someone tells you that they're not lying to you doesn't make it true. So maybe the second sentence kicks in for you. You say, I doubt Kyle's claim, and maybe you want to test to see if the coin is fair or if it's not fair. Does it have an equal chance of flipping heads, tails, or does it not? So of course, to do this, since you're at home and have nothing to do, major for the next couple days, you decide, why don't you flip this coin 900 times, right? And just record if you get heads and tails. Now, if it's a perfect 50-50 split, how many heads and how many tails would you expect to get? Well, you could think about that. It'd probably be, what, 450 heads, 450 tails. Well, let's say you get 459 heads. Well, that's more than expected, right? I mean, you were thinking it should be about half-half if it was fair. So maybe that's evidence that I didn't give you a fair coin. Or maybe that just happens by random chance and, don't get all worked up. I probably didn't lie to you. Well, again, these are our two hypotheses. So let's go ahead and start writing this out. So how about when we write out our two hypotheses, let's have P stand for one of the percentages of flipping. So how about we'll say that flipping one of the sides. So how about we say that, oops, let me write this. P represents the probability of, let's say, flipping heads, since that's what we were counting in the question. So H0, remember, always has an equal sign on it. H1 could have almost any sign on it except for an equal sign. So let's see. We want to test to see if the coin is fair or if it's not fair. Well, if the coin is fair, then the chances of flipping heads, well, that should be 50%. But if it's not fair, again, this has nothing to do with the info that I have in the question just yet, but if it's not fair, then that would just mean that the chances of flipping heads is not 50%. And it is automatically this not equals that gives us that this is a two-tailed test. So we're going to keep our eyes open for any time that we come across a not equals in a problem like this. Again, the way that I am determining this is by reading the question and thinking about it. I was trying to determine if the coin is fair or if it's not fair. So is the chance of flipping heads 50 or is it not 50? Okay, now I can go to my test statistic. I'm going to write down all the information that can be used as my evidence. Okay, so I have an X. I flipped the coin and I found 459 heads. I had an N. I flipped the coin 900 times. I can then calculate a P hat, which would be 459 out of 900. If I was to go ahead and actually crunch this on the calculator, let's see what we come up with here. 459 out of 900, well, that's 51%. Okay, I want to know if that P hat is weird to happen by chance or not weird to happen by chance. So it's time to do some checks. All right, so let's see, I'm going to do 20 times my 900. That would be 18,000. So I want to know capital N, or little n stands for the number of times I flip the coin. Capital N would stand for all of the times I could ever flip the coin. Could I flip the coin more than 18,000 times? Well, sure, I don't really want to do that, but I could. If someone tasked me with doing that, I could definitely finish the job. So, all right, we'll deal with it. All right, then I'm going to do 900, remember, times P, not P hat, times P. And right now, I believe, since I'm testing hypothesis 0, that P is going to be 0.5. And so 1 minus P is also 0.5. All right, if I crunch that out in the calculator, let's see. That's going to be 900 times 0.5 times 0.5. And the result comes back as 225. which is definitely greater than or equal to 10. So just like last time, we can say p hat has a normal distribution. Perfect. The last thing I want is a z-score here, but again, I'll do that with the next step. I know that all of my p hats line up on a number line. They fall into a nice normal distribution. I'm expecting 50% to be sitting at the middle. That's what I expected because, again, I thought that p was going to be 0.5. Strangely this time, though, I didn't quite get that. I got 0.51. That was our p hat that we got in our sample. And I'm curious about something. Notice here that since we have a two-tailed test, and I got something that's above average, I am still concerned how high above average does it fall. But the fact that it's two-tailed means that I'm equally as concerned about values that would have been too low. So if I would have got something like 30%, that would have still been alarming. So I have to kind of do this double shade when I have a two-tailed test. What this means is that that p-value is the combination of these two amounts. And I can easily think about how I would go ahead and get those two amounts. I should be able to get those two amounts by saying a couple things. First, I could grab the probability that p hat is greater than 0.51. If you look at the picture, you could see what shaded space that should correspond to. And I don't think it's all the blue space, but it's only some of it. If you shaded the stuff that's only above 0.51, you would only get this space over here. But if this is a symmetrical curve, then the amount of space on the left shaded space is equivalent to the amount on the right. So I can just do a times 2. Like whatever answer comes out of the right tail, double it, and you have all of it combined. The cool part, again, is that if we tell the calculator all this information, it will compute all of this automatically. So I'm going to go ahead and do that. Before I type everything in, though, I will mark where my z-scores are going to occur on down here. Notice I don't know the z-score yet that goes with my blue value. I'll figure that out in just a moment. Okay, so let's see. I'm going to go back to the calculator. I'm going to go to tests. I'm going to go to that number 5, that one prop z-test. And here's all my information. This is the information we had in the last question. Again, my p0 really hasn't changed. I believe that the coin has at least for the moment, is a fair coin. We flipped the coin 459 times as a head out of 900 flips. And remember that down here, this is my alternative hypothesis. So the question again is, do I want p to be not equal to p0, p to be smaller than p0, or p to be bigger than p0? Keep in mind, p0 is just 0.5. Well, in this case, we had the not equal. So then when I go to calculate, calculator automatically now knows exactly how to find that p-value. And you can see all the information again is given to us. I have my h1 given right at the top, then my z-score is given. Then my p-value is given. And notice that the calculator actually already doubled that particular value. I don't have to worry about that value not being doubled. Because I told the calculator it was not equal, it already did the times 2. And then, of course, I have a repeat of my p hat and my n just to check all my work. On this question, again, I want to know, what was my value of alpha? What was my measure of being rare? So I want to go back up to see if it tells me alpha or level of significance. Let's see what it says. Perform the appropriate test using a 10% level of significance. Perfect. So that means 10. If something happens under 10% of the time, we'll call it rare. So did we see a rare p hat? Well, our p hat happens 54.85% of the time, so definitely not rare. So we can see here that our p-value is greater than our alpha. So we definitely have something that is not rare, and so we do not reject H0. Or another way that's acceptable to write it is you say, I'll stick with H0. I couldn't really say that I pick H0 because I've kind of already picked it. That's why I'm trying it on. So it's like once you have it on, you either stick with it or you get rid of it. Okay, time for my conclusion. Same as last time. I'm going to start with an interpretation of what I found. So I'll say it is very likely to get a sample percent of 51% by chance if the coin is fair. Like, it's not weird to get 51%. That could totally happen. It happens over half the time. That's crazy. Okay, so if that happens over half time and it's not rare, then I can state what it is that I believe. So I can say, so we have no reason to doubt that Kyle's not lying to me, right? I don't have any reason to doubt that that the coin is fair. It seems like this could have totally happened by chance. We have no reason to doubt that the coin is fair. I'll also put down here as just an alternative. We could say we could instead say we don't have enough evidence to conclude that the coin is not fair, right? Like, we didn't find enough evidence to go with H1, or I have no reason to doubt H0. These two sentences here that I have at the very bottom essentially say the exact same thing. I would never care which one you use. You'll see often in my notes, I even kind of alternate between them from time to time, just whatever naturally kind of comes out. Okay. Hopefully you can see that this process of doing one of these tests is still pretty consistent, whether I have left tail or right tail or two tail, but it's just that when I have this two tail test, I need to make sure I remember to shade both sides, and then I put this times 2. And I have to remember the calculator already knows to do that when I tell it to not equal. Okay. Again, this process can seem a bit overwhelming, but over again the coming weeks, we're going to see that all we're going to do is continue to rehearse this idea over and over and over again. Take a look down here really, really quickly at the very, very last problem, and it looks like otherwise I got a blank page here as extra. What type of error might we have made in this problem? Okay, well, first I have to think. What hypothesis at the end of the day did I go with? Well, I went with H0. So I'll say we stuck with H0. So we may have made a type 2 error. Remember, you can only make a type 1 error if you went with H1. Yeah, so we may be wrong. Again, do we know if we're wrong? No, we have no idea if we're wrong. But it seems like all the evidence is pointing us towards, I'm not a liar. Kyle didn't lie to you. Okay. The problems in the homework are going to be very, very similar to these sorts of questions here. I think there's one that asks about like a newspaper publisher and like a percentage of people that are going to subscribe to their paper in order to be successful. And it operates just like one of the questions that we have here. It is not a two-tailed test, so it's actually more like example number 3 than it is this one. Okay? Of course, if you have questions on this content, please let me know, and you can see me in office hours, shoot me an email. Otherwise, please make sure you go to the worksheets and you try to practice this. Practice is your #1 way to improve. You got to go through and actually sit down and try to work through some of these examples and get better at reading and interpreting and seeing what they're saying. Okay, in the next section, in the next video, we'll talk about 7.2, where we'll kind of repeat the exact same process, but instead of looking for mystery percentages, we'll look for mystery averages. All right, I'll see you there.